The last example we're going to see, it's an equation. I'm looking for what works for x. Being rational, being the fact that I have denominators and I have an x down here, probably what is we learned last time, I should identify first are, what are my restrictions? X can't be 5, change the sign. If x were 5, I'd get an extraneous answer here. X can't be negative 5, change the sign. If I got a negative 5, it would be extraneous here. Those would be undefined. I can't have those numbers. When I solve, I don't know. Am I going to get one answer? Am I going to get two? Is the one answer going to be extraneous? If so, no solution. If I get two answers, maybe one's extraneous, maybe one works. If I get two answers, maybe they're both extraneous. Let it play out the way that it plays out. As long as you know what you're looking for, the problems will all be very straightforward. So just get in that routine and check out the different examples and the different way things may play out. Now, the big problem we have here is all these fractions. Our one step, get rid of it, multiply by my LCD. Now, in order to get a common denominator, being that they were polynomials, I would want to factor and I would want to look for what's missing. What's nice about this problem, I have a difference of squares over here. X plus 5, x minus 5. What's nice is everything's represented. I do have an x plus 5. I do have an x minus 5. That one denominator happens to be my LCD. Technically, nothing's going to miss. Because what's going to happen here is that since everything's represented, everything will get a chance to cancel. Multiply that by each term, meaning over 1, put that LCD in each numerator. Multiply the numerator by the LCD, multiply the denominator times 1. What I'm going to have is 3 times x plus 5, x minus 5, over 1 times x minus 5 is x minus 5, whether I have it in parentheses or not. Plus, I do want to show, I'm going to keep that 1 there just so for record keeping. I notice that I'm not missing anything. X plus 5, x minus 5, over 1 times x plus 5, there it is, equals 2 times my LCD, just again so we see it, x plus 5, x minus 5, over my denominator. And I'm going to leave it in factored form because I want to see what's going to cancel. And here's what I'm going to have is, I have the same fraction, 3 over x minus 5. I have the same fraction, 1 over x plus 5. I have the same fraction, 2 over the factored form, x plus 5, x minus 5. But what I have is that LCD in each numerator. I haven't changed anything, but what I've set up is a whole bunch of canceling. And when I cancel all of this, what I'm going to have is 3 times x plus 5 plus 1 times x minus 5 equals, that's kind of nice, everything cancels too. And when we look at how much simpler this equation is, once I've multiplied by an LCD, that's going to be our big tool. Now again, we still could be hitting restrictions. Don't rule these out yet, but let's see how it plays out. Distribute, great. Distribute, great. 3x plus 15 plus 1 times anything, that's kind of nice and convenient, equals 2. Combine my like terms, 3x and x, awesome, 4x. 15 minus 5 is plus 10 equals 2. Okay, that's great. Everything's working out nicely. Remember the fact that I have just an x means great. Subtract and divide. Had that been an x squared, I could be taking a square root. I could be needing to factor. And remember all these techniques, just keep an eye out for those indicators for what steps need to come next. Minus 10 to each side gives me 4x equals negative 8. Divide by 4 to each side gives me x equals negative 2. Now remember that negative 2 is what I'm saying should work back in the original equation. Now, the ones we had to watch out for were not negative 2. The ones we had to watch out for were 5 and negative 5. Had I gotten negative 5, I would have put extraneous, and in this case, I would have put no solution. But what if I had an x squared, and what if I'd have had negative 2 and negative 5? I would have put a big x over that negative 5. It would have been restricted, but that negative 2 still would have worked. Extraneous does not mean no solution. No solution means absolutely nothing works. Extraneous means that one number is restricted, that one number doesn't work. That's what extraneous means. In this case, -2 will work.